Well, hello, everyone, and welcome to the February 2024 edition of the St. Louis Java Users Group. Next slide. For those of you who don't know, the St. Louis Java Users Group has been around for quite a while. Our first meeting was in May of 1997. We haven't missed very many meetings since then. Attendance is free. There is no formal membership list. Our normal meeting date is the second Thursday of each month except December, when there is no meeting. There's just too many things going on over the holidays for us to be able to organize a meeting in December. If you're joining us in person, you can join us for food when it arrives at 6 p.m. and for social at 6. And we try to get our meeting started as close to 6:30 as we can. I'm sorry we're running behind today. When we meet in person, our normal meeting location is the Object Computing Incorporated Training Room, and that's at 12,140 Woodcrest Executive Drive, Suite 310 in St. Louis, Missouri. Next slide. I'd like to introduce you to the members of the St. Louis Java Users Group Steering Committee. So from left to right, we have Ted Doyle, Bruce Olspo, that's me, Robert Levitt, and Wei Chi Gao. You can reach all of us on the St. Louis Java Users Group Steering Committee if you send an email to the address at the bottom of your screen. That's javasigsc@ociweb.com. Next slide. And I'd like to introduce our newest member of the St. Louis Java Users Group Steering Committee, and he's here today, Zach Klein. So welcome aboard, Zach. Next slide. The St. Louis Java Users Group would not be possible without the help of our sponsors. So I have their logos up. First off, it's Object Computing Incorporated, and they have been with us since the beginning in 1997, and they fill in and they've helped us. They've sponsored the training room, and it looks like they'll cover the pizza tonight when it arrives. JFrog has also been good. They cover the cost of the Zoom subscription. So it's free for you to come in and use that Zoom link, but it does cost us a subscription to have an account on the Zoom website. At the end of the meeting, we will be raffling, get this, usually it's 2 JetBrains licenses tonight because we're helping advertise one of their meetings. We're going to raffle, in addition to that, 2 more all products packs. But you must be present to win. So if you're watching the recording, I'm sorry you're too late. You need to be present either online or in person. And we will also be raffling 2 Manning ebooks of your choice at the end of the meeting. And I should also say, we are looking for additional sponsors, particularly for things like food and pizza and things like that. You know, so we kind of had a little problem today. We could use additional pizza sponsors. We used to have big companies like Enterprise Holdings, MasterCard, Edward Jones, and some others, and we're trying to get that reestablished now that we're back from the pandemic and meeting in person. We need to reestablish those connections for sponsorship for food. So if you have any connections over there, have them contact any of us on the steering committee, and you can use that website I just gave you. So Manning has been nice. They've been giving us a 40% off discount on any product. So when you do the checkout, you can use that discount code JUG13. And below that, here's the reason why we're doing additional licenses tonight. They have a online conference that's free. You might want to take a screenshot of that because it's kind of a rather lengthy URL there to sign up. And if you'd like to go to their free online conference, that's that jumbled up website to go to. So you may want to snap a photo of that one. Okay, next slide. Also, Developer Week has some free open passes as well. That will be later this month. And that one is easier to remember. It's just developerweek.com, and you can just sign up there. And but we do have a registration link posted on the Meetup bulletin board. We get that way they know they found out about us through the group if you go that way. The No Fluff Just Stuff conference is coming up, and I believe you know all about that. Our speaker tonight here, April 5th and 6th, that will be both online and in person. And Jay has given us a JUG discount code there, and it's on your screen, JUG 100 NFJS 24. If you want to get the details on that, you can just go to their website. That's nofluffjuststuff.com/St. Louis. Next slide. And it's not too early to talk about the DevNexus conference that will be in Atlanta, Georgia. And one of us, I think, from the steering committee of the St. Louis Java Users Group will be there. That's the largest Java conference that we know of in North America. It's a fantastic conference, and that thing just runs like clockwork. I'm amazed. But it's devnexus.com. And it turns out that we have a sister Java users group in Kansas City. As people know, I'm actually in Columbia, which is halfway between St. Louis and Kansas City. Well, I've been going to St. Louis this time. But they will be having their conference here coming up, and you can get the details on that at www.kcdc.info. So those are all the conferences here I need to talk about. Next month, our upcoming presentation will be creating realistic JUnit test with test containers. So yes, we're going to be putting Java in the container. You got that one. Specifically a test container, and that will be done by Paul Balo of Grafana Labs. I'm not sure if he's still with Grafana Labs, but has been. And Paul is quite familiar with this because he runs the Go group as well as the Cloud Native group, believe it or not, from this very training room that I'm in right now. So he will be here talking about test containers next month. So if you want to keep up with the presentation schedule, that's easy to do. You go to the meetup group, and that's where you get the updates to the presentation schedule and location, whether we're meeting hybrid or in person or however we're going to meet. That's where the announcements go. And if you're interested in giving a presentation or serving on the steering committee, or perhaps you know someone who can sponsor food for us, let us know at that email address. Again, that's javasigsc@ociweb.com. So enough of me. You've all been waiting too long. So I think I'll turn things over here to Ken on architectural principles here.
Test 1, 2. All right. Thank you. Awesome. I might make one bit of recommendation. It might be really cool to have QR codes for those links so people in the audience just jump there. It'd be kind of magical experience. The technology, right?
Yeah, there's a bulletin board on the meetup site. Believe it or not, there's a little menu you have to go through. And if you go through that menu, you'll see all the different postings. And I see conferences. Yeah, so that's meetup.com/KH. And then from there, you look at it.
All right. Well, a couple of just logistical things. First, I'm on camera, but I don't know why here on my screen, because I'm a walker when I talk, so I have to. It's that, so they're going to see a wall or something, I guess. Second of all, yeah, I was brought here by Jay. Jay asked me to be here. He runs the No Fluff Just Stuff, NFJS. I've been with NFJS since 2007, maybe something like that. 2006, I started. 2007, I went. Well, Jay never calls it this, but I call it core. There's a core group, ones that fly around, go every weekend, every other weekend usually, to different cities. I stopped that some time ago. So it's been a while since I've given a talk. I have a challenge tonight. I don't know how long we're going, but we have to wait for pizza. My slide deck usually is intended to run 90 minutes, so I don't think we have that. I'm fine. Well, until you guys fall down, we'll see what happens. Second of all, I've never done this one yet, so it's brand new. You guys are going to help me refine it, maybe, hopefully. You might give some suggestions. Not going to hurt my feelings. Yeah, so when I try to squeeze a 90-minute talk into 60 minutes, sometimes I go rapid fire. Unless I'm in a foreign country where I intentionally try to slow down because cognitive load, that kind of thing. But you guys aren't foreign to me, so we're gonna go full bore. I can go. Cool. Jag förstår Ica. That's it. Norwegian for you friends out here, which means I don't understand. There's a story to that. I'll give it to you later. So what else? There are some things I might just bypass quickly. If I do and you're interested, just stop me. Also, most of the slides are like they're guardrails for me. They just help guide my conversation because I just, I just vomit out architecture. I guess I don't know. No. Also, you saw the slide. I didn't know that was going to be there, and it's totally fine. I usually introduce myself as being with the fintech in St. Louis area. I don't represent Jones here. That is where I'm working, so I don't mind. I don't mind you guys knowing. Frankly, you go to LinkedIn, you're going to find it. So, but no representation whatsoever. If I normally would have be affiliated with that company, I would want to have their compliance. There's a whole process. So I'm more representing NFJS and just myself, if you will. So, you ready? All right, let's do it. We'll see what happens. Like I said, I don't know. That's me. Some things that are, I don't focus usually on this, but for certain talks, I might call out a few things. One, I was one of the first 10 people trained by Rational who were outside of Rational, meaning consultants, to teach their courses. So I used to teach RUP, Rational Unified Process, UML, which I apologize for. I was young, I needed the money, and Rational Rose. So this is, they were the Cadillac in the space of architecture for a long time. Frankly, the people I admired and read their books and just truly were inspiring to me. Grady Booch, Jim Rumbaugh, Ivar Jakobsen, they all worked at Rational. So they are the people, right? They really drove a lot of our abilities to provide notation and process and a variety of other things. I don't know if I bring much of that here. I'm just, and that was like 97. So I've been doing architecture for a very long time. And I dive in and out of being kind of a manager and being an IC, individual contributor. I'm kind of in a manager role now, but I still also am a CNCF committer. And I'm a contributor to Kubernetes. So I have a number of projects that I work on. I am normally in the Go space. I did love the advertisement for Paul. I've done a number of talks on Go. In fact, I have one coming up on a webinar. It's a half a day of what is it, Go for Java developers. So it assumes Java development and makes some comparisons, but mainly a focus on Go. I've been writing mostly Go, frankly, for the last maybe 4 or 5 years. But I still play pretty strongly in the Java space as well. And we're going to talk architecture. If you guys want to debate languages, we can, but that's not going to be the major focus. I think that's it. That's how to get a hold of me on X, which I rarely am there. No, I'm there as a consumer mainly. I keep in touch with Venkat and a number of other friends in this space. So architects, it's hard to know where to start with such a talk. It's really challenging. Do you hit the high? Do you hit, where's the basis of understanding for people? So I actually I have a few slides. I'm also, as advertised, looking for feedback. If you're like, hey, this intro doesn't go with what's going on here, then I would appreciate that. I really am looking for feedback. So architects, what are they? What do they do? Why do they exist? Let's dive through it. Well, we could switch to a very famous, pretty well-known architect himself, Martin. He says that they share an understanding that expert developers have of a system design and decisions you wish you could get right early in a project. That's interesting. Is it weird that we don't have like a firm, this is an architect and this is what they do? It's a little nebulous, and we start to kind of see some of this. Architecture is about the important stuff, whatever that is. That's a quote from Martin, right? Whatever that is. The challenge here is, you could be building a mobile app system for which architecture could be very important. You could be building a web application. You could be building a trading system. All of those things require a different level, potentially, of regulatory concerns, of security concerns, of just how the system is designed and how it might evolve. So it's really, really challenging. We can get to the meta level, which is also challenging for humans. I have found through my career that humans, most of them, struggle with abstractions, which I think is one of the core things you need to know and understand as an architect, by the way. So we could have a whole conversation on that. I have a couple of slides that we'll get to eventually. So, and how do you teach abstractions? Well, generally you teach concreteness. You're like, well, this is a chair and that's a chair. And you can say, well, the thing that is similar between these two things is the thing that makes it's the thing that defines chairness, right? So we start to look at concrete things, we start to compare that and can pull out abstractions. And we'll talk a little bit more along those lines as well as we get further along. So architecture, I went to ChatGPT. If you don't enjoy Martin, I'm not going to read the whole thing, but I did call out some embolden some words here. Designing the overall system structure, that seems consistent regardless of the nature of the software that you're doing. And with a focus sometimes on what I sometimes refer to as the illities, right? Or NFRs, which means non-functional requirements. But you're into scalability, maintainability, and efficiency. So those are some core elements. Actually, I was thinking of doing a whole talk, having ChatGPT the whole thing for me, and I failed at that. When I do an interview, which I commonly will interview architects, I almost always start with this. When I think of architects, I think of them as being T-shaped. And by T-shaped, what we mean is they have a long breadth of experience across a large number of things, but they also have some depth. Now, I've met plenty of people who have a lot of breadth and no depth to them. And I don't tend to hire those people. I have my own biases, and we can talk through that if you want, but I just don't. Oftentimes, I will get people who claim to be architects, and I call them paper architects, which is a weird term that I use. And what I mean is they know Word, and they know Visio, and they know PowerPoint. That's the extent of what they do. They create diagrams, and there's probably room for them in many places, right? Because doing diagrams and documenting that stuff is super important and useful. But what they tend to lack is the depth of understanding of consequences, which we're going to talk at length of today, okay? Also, that depth could be in multiple things. Usually it's one deep thing. When I'm interviewing somebody, my process is fairly simple. I never have the same script, by the way, but I do have a meta script. We're going to talk meta a lot tonight, right? And that meta script is I talk about the T and what it means, and then I ask them where their depth of their T is. And then they tell me, and then they might say Java here at the JUG, right? So I would expect many here would likely claim Java is their discipline. And then that's what drives the rest of my interview. I will find out how deep your T gets. And wherever that goes, you're weaker in all other areas. That's my bias or premise, right? And I know how unfair that might be, right? We're going to have a long conversation. I would also say that one of the other needs, super important needs of an architect is the things that are soft skilled. And it's super critically important. We have to have influence, and we have to have this ability to read the room. Now, we're going to get to some of that conversation, but I'm also expecting that as well when I'm interviewing. So, by the way, since we're here and we said Java might be our deep basis, one of my favorite interview questions around Java folks who think they're deep is, well, what is the thing that is most irritating to you or frustrating to you, or your pet peeve about Java? Because the thing is, if you barely touch Java, you're going to either not have one or you're going to have something pretty surfacey. When someone tells me, dang it, I have struggled with so much time and energy on the difference with reflection on primitive types and object types, then I know I've got somebody I'm really interested in. And I know their T goes deep, right, for Java. That's just what I can look at a resume for a Java person, and a common thing you might hear me say is, well, they're a really nice guy, but it appears they have 9 years of experience, but it appears they have 1 year of experience repeated 9 times. That's a whole different thing than going deep for 9 years in a language, right? So, and I'm giving you, you believe, I'm getting smiles, so that's good. I feel like I'm in my in crowd, so that's good. So I want to know how wide you go and how deep you go. And I have a fairly younger architect working with me right now, and we've started having meetings. And I've been going with the purpose of advancing or elongating the length of his T, the breadth of his T. And he's mainly a user experience person. He's normally a node. We could go through a list of things, but what he's lacking is networking, infrastructure, all kinds of things. So I started just interviewing him. He already works for me. I just started interviewing him. And we find his gaps. And when we find his gaps, then we start filling it, right? So it's a really, really neat and interesting experience. So where do architects come from? Well, that's an interesting question. Did you know you could go to college and can get a degree in building architecture or in like civil engineering? And actually, it's a very meaningful thing. Have you ever seen somebody go through college to become a software architect? I don't even know if that exists. It's not a thing. Where do they come from? Well, it turns out that we have developers that grow up and they have a choice. Do you want more money? Do you want more prestige? You have two choices. You could become a project manager or an architect. Now, the challenge with the term architect in our industry is it could be a label that is rightfully placed. You do architecture, or it could be a rung on the corporate ladder, which may be that you're the most seasoned developer. And the problem that I have is I don't know. I don't know where your experience is and where you're coming from. The problem is that doing real architecture sometimes is obfuscated by the corporate world. So what can we say about a really amazing engineer? Well, a really amazing engineer, like one of those 10x developers, right? A 10x developer, what are they good at? Well, putting on the cone of silence and jamming some code out, and they're amazing. It means that they have some depth to them. What are they lacking? What's the challenge as they get promoted to be a developer? Or frankly, a project manager, it really wouldn't matter. Any thoughts on that? What's the challenge? Soft skills, thank you. You know, it's really challenging when someone's absolutely the superstar, the golden boy or girl, right? And then all of a sudden they get put in this position and they're like, I want 2 of Ken's. I want 5. Can we make more? Can he lead more like that? And then they're like, he was doing so good, but now I'm questioning things. What's wrong? Well, the learning curve begins again. And this is the hard part, right? The hard part is the things that made you amazing as a programmer or as an engineer, they're still valuable and useful, but there's a whole new set of skills that you're going to have to relearn. And it's dealing with people and influence. It's about looking at and understanding consequences. And we're going to walk through a lot of the principles as well. So I already went through this. What makes it great? What makes a great architect? Well, that's questionable. That's a hard one, right? We could spend some time on that. Maybe we'll see what comes out of this. What do architects do? Well, there's a couple of slides. I'm not sure if they fit. This was the one I was stuck on as I was last going in. You're usually going to be looking at system architecture, logical views, physical views, potentially deployment views. You're kind of defining the tech stack in many cases, a variety of things you might define. What we have to be careful of is there's different types of architects, which is coming. So maybe I'll hold that for a second. You also might be looking at infrastructure. Each one of these might be different architects is my main point, by the way. So we might have an infrastructure architect. That's the other thing. When I have architects come in and we're interviewing, I'm working in enterprise architecture, so we see the whole breadth of the entire enterprise, which is hard, by the way. If you're interested, the hardest thing about being in EA is that you need to provide guardrails, but you can't be too prescriptive. When I'm an application architect or a solution architect, roughly the same to me, I can say this project is going to use Spring MVC. And I can define, oh, we're going to use Java 21, and we're going to use Spring MVC, and we're going to go through the list. I can be very prescriptive. And it helps to provide guidance and direction for the dev team. And it helps to provide some consistency as well. And if you're lacking some awareness in the Spring MVC, you can go dive into that, become somewhat of a quasi-expert, and then dive into it, right? Why can't I be prescriptive in EA? Well, because as an enterprise architect, if I define one thing, it means I'm boiling the ocean. I can't do it. I have to say, you know what? We prefer request-centric based architectures as opposed to component-based front ends. Now that's something significant. It's somewhat prescriptive, but not overly prescriptive. And so we get into those different levels of abstraction, which becomes, again, problematic because humans have challenges with abstraction still. So when I get an infrastructure architect in, you know what? I'm going to dive. Okay, this is your space. Tell me about a layer 4 load balancer versus a layer 7. Tell me how they're different. Tell me when I'd use one versus another. I need to know. If you don't know that, then you're not the right person. And it doesn't mean you can't learn it. It just means if I'm looking immediately to employ somebody who's an infrastructure architect, I need them to already know those things. And those are baseline stuff. Now, at that point, I want to know which specific layer 7 and layer 4 load balancers you're used to using, all right? So those are the kinds of things I might be interested in. So what do architects do at the most abstract level? We fight entropy. What is entropy? Entropy is kind of comes out of more of a sciencey or a physics world, but it's the fact that the universe is always falling into chaos. It moves from order to chaos, and the goal and guide of architecture is to help encourage guardrails, to encourage a directionality that provides order. Yeah, is that cool? Oh, I'm glad this is recorded. I just kind of off the top of my head, so I might need that later. So we fight entropy. Now you can't tell your boss that. What the heck? Like, what? The funny part is I do talk like this oftentimes and drives people crazy, but they still employ me, so I keep talking. So different kinds of architects. We mentioned a few. I'm going to shorten this a little bit because we already hit a few. We got business architects. That one's a little foreign. It's a little different, right? But you're looking at value streams and capability mappings and things that probably in this group are foreign. But what they do is they align business value. They look at a value stream and they see gaps and they're like, hey, or they see redundancy. They're like, wait a minute, we got 3 systems that add the same value to the business. Can we make that one? Right? You go through the 6 R's and you're like, well, we're going to retire that. And we're going to re-platform that and things of that nature. Well, we do have a role called a product owner, but we also have a role called a business architect. And oftentimes they might be interfacing with them. But the business architect's also looking a little bit more towards the business, not just the product owner. And they are looking at the value streams that span across multiple things. The product owner is going to be like where the product owner would likely fit is when a business architect comes in and has the value stream. There are going to be different applications or products that help to deliver the value of that value stream. And a product owner is going to own one of those or multiples. But the point is they don't often own the whole stream unless you have a small enough group. My danger here, probably the hardest part of what I have to do here is we're going to get to talking about some scale and things like that. I'm not talking about high level consequences and concerns that likely don't exist in the Midwest. And that's okay, right? That's super okay. Problem is there's going to be a bunch of people here that are like, I'm going to build my resume and I'm going to make the most scalable platform on the planet. It's cool. It's expensive. And the question is the juice worth the squeeze, right? Like, is it valuable to the organization or could they get by with less? And that's the balance. In fact, there are 2 times I see architects argue the most. One is they are arguing unknowingly, right? This isn't called out explicitly, but they are meeting the problem at different levels of scale. This guy's always wanting to use JMS and messaging. We have to go asynchronous. And this one's like, hey, you know what? This will solve the problem. But maybe it won't scale as much. And so you get like, what is the defined level of scale that we are solving for so that we can unite in our discussion? The other thing that I see architects argue about all the time is, oh, I lost my train of thought. There's a second reason they argue. Oh, time. You could be solving something in a like, you could have an architectural roadmap and you are trying to solve for the North Star, the pristine, the golden thing that you're after, right? The target architecture. But somebody might be currently in the current state and now they're having an argument because they are on the wrong time scale and they don't know it because it's a weird thing to call that out explicitly, but there's value in being explicit. You'll see that commonly I'll be overly explicit, but that's just my nature. But also it avoids confusion, all right? Well, one of the things I'm challenged by often as I go around speaking is I have someone quote me and have me on a solid position for something because I stated something. And what I have to just look and shake my head and laugh at, now I'm older and I've seen it enough times that I'm like, yep, there it is again. I could probably have as equally and passionate counter position, but they don't know that. And I don't know in the moment that they needed that because I was making a point for whatever it is I was talking through at the time. So yeah, challenge me. Let's do it, right? Bring it. Business architects, application architecture, solution architects, domain architects. What's that? Well, we have somebody on staff that their whole business is Salesforce. That's what they know. They know it deeply. We have a whole person on MuleSoft. That's what they know. They know it inside and out. They know it very well. On the Salesforce side, literally certified Salesforce architect, right? So there's a certain level of need or understanding that they've been able to test out and verify that they have. Those are super useful when you have a large enough org, and we often interface with them to ensure that we're doing what's best for that platform. The one that is often confusing as well, just like business architect is information architect. I wish we had more of them. It's a little frustrating. I see the absence of them all the time. What happens when you build out your first X drive, Z drive, right? Your shared drive that the corporate world provides you. It's wonderful at first. You're like, oh, I was running out of my terabyte of drive and I have this other thing. I'll just start putting things out there. What happens a year later? It sucks because it's just this dumping pile and I can't find a thing. That is where an information architect comes in. What goes on SharePoint? See, I'm talking off Microsoft tech now. It's weird for me. I'm getting used to it. It's a pain point for me. But what goes on SharePoint? What goes on Confluence? What goes in the GitHub wiki? We could go through the list of places information can go. My current angst right now is everything I write is in Markdown and GitHub. And there's a bunch of people that I work with super challenged by that. They don't understand Git. It's like, this is what a high-tech company does, period. I don't fight Clippy. How many times it's funny because I call it out every time. Every time they get in and they start monkeying with Word online in front of a group of people and they're fighting the tabs or they're fighting the table. I'm like, see, Markdown wouldn't do that. when the software thinks it's smarter than you. There's a couple of concepts or check-in points that we need to get through. I didn't know how to fit it in, so I just thought I'd call it a check-in point. It'd be fun. So, loose or tight coupling, which one's better? This is where we have interactions. What's that? Loose, loose, loose. Loose, loose. We got it depends. You're a consultant. I love you, by the way. So, okay, the audience, I'm repeating for online, but drive towards loose, but it depends. Okay. Once again, likely to be asked in any interview I have of an architect. And what I would also say is one of our strongest pain points in architecture is the fragility or the fragile nature of our architectural systems. And because we have that pain point and because it dominates our industry quite a bit, we have people screaming loose, right? Like, so all of the writing is going loose. By the way, this is how I know you're going to be a good architect. Because what I will ask, it doesn't matter how you answer that question to me in the interview, because I kind of know now. I know 80% will say loose or better, right? But I will always ask you the counter question. Well, tell me a time when it doesn't make sense. Because depends is the right answer. Let's talk about it for a second. What systems would not function correctly in a loosely coupled system? What category of systems makes sense to you for which that's true? Yeah. Database indexing. Interesting. It's very specific. I do like that you need some level of, well, we could talk through that more. We're not there yet, right? We got to talk about consistency and all kinds of things. Love it. Right on it, right? So find a category, something that falls into something that requires low latency. How about a trading system? Trading systems, you know what made, and by the way, some really good writing on this in the last, I don't know, five years or so. What was it? Dark Towers, maybe? What they were able to do with the dark pools, essentially trading systems, is they were able to gain several milliseconds difference, and based on that difference, we're able to be able to leverage that latency that everybody else gets to make tons and tons and tons of money. Also, You pay for different levels of services in trading systems. You could pay, like we're normal consumers, you get your phone out and it shows you a stock quote. That stock quote is probably minutes delayed, right? But that's what you get for free. And we all have access to it. You can pay, you can get a trading system like on Charles, what is it? Charles Schwab. And you might get it a little bit quicker. Guess what? You could pay big money and you can get it within milliseconds. And there's a difference. Yes. Yep. We're gonna get there. I love So that's a lot of words. I can't repeat all those. But what I heard was a couple of things I want to call out. One's you're still in the depends camp, which is awesome because that's right. And it requires context. Totally agree. 100% with you, right? 100%. Also, we could claim that I like where you're going because it's a good segue to my next thought, which is both are needed. Both are absolutely needed. What do we mean? When we're building the component, we want tightly coupled. When we are building between components, now it's questionable. In a low latency environment, I might have tighter coupling. In a system that can tolerate a higher latency or requires higher levels of scale, things like this, well, I might loosen the coupling. We can get into some more of that. Maybe. I'd have to think about that. Yes. Okay. In the 90s, Microsoft came out with a technology they called COM. It became COM Plus, and then it became .NET, right? Or COM, yeah, .com, or no, what is it? DCOM. No. DCOM is the distributed COM, and then COM Plus, and then you'll find like historically, in fact, we're in a Java shop, so I can easily say this now, but I was working a lot with Corba, with a variety of options there. VisiBroker was my thing for a long time. And I needed to integrate into Microsoft solutions, which at the time were COM. And you can likely still find my name associated with JCOM, which was a Java interface into the COM world. Right. So again, this was mid to late 90s, 96, 97, 98 timeframe. Java 1. So what did COM do? And I'm bringing this up for a couple of reasons. COM objects are nothing more than a DLL that have a dual interface. What does that mean? Well, we attach another component to the DLL, so I can connect to them directly, tightly binding to the DLL itself, or I could do it more loosely, right? Which is I could use the IUnknown iDispatch interface, which is the IUnknown is, hey, tell me what you can do. Oh, here's a list of things I can do. All right, do that thing. That's the IInvoke interface, right? Which did everybody use? Well, everybody compiled directly to it and used the DLL, with the exception of a couple of things that I noticed. We used we loosened our coupling to it when you had a tool like Visual Basic, and there were other tools like it. Delphi comes to mind and some other things. Or I had a bridge. I'm going from one technology to another for which I can't control certain things, right? And so an element of control matters. An element of control, let's say control. What are the things I can't control? I can't control third-party vendors. I can't control product type things and their evolution. I might want to abstract, which means I also might want to loosen my coupling because I have an unknown environment, right? So both added value, but most people were looking for performance, and there is latency associated with a loose couple. And you're going to begin to see, hopefully throughout the whole presentation, that we're going to talk about one thing, and then it's going to refer to another thing. We're constantly going to have consequences of competing interests throughout, right? So here's a slide I've used for 20 years now. And the question is, when you first saw it, How many abstractions do you see? Now, 80%, give me a number. So I assume I have 80% of those people here as well. What's the number of abstractions what's the first reaction you had? Yeah. Money what? Money piss? Yeah. Okay. How many, not I'm not looking for an abstraction yet. How many abstractions do you see? 2. At least 2. Okay. What are they now? Perfect. I love it. Okay. Now, what's beautiful about this is, what I love is I've been in many countries, so certainly Norway and India, and Poland, and they all think the same way. As humans, we see the same thing, which is awesome. There's something about it, right? And you define something that is easy to, once you say it, you can't unsee it, right? You could go, okay. Now, I'm going to ask a couple of questions. We'll have a follow-on conversation. First, could you see 6? Yeah. Now, the harder one. Could you see 1? And what would it be called? Object, maybe? Thing? So it's too abstract, right? But couldn't it just be image? Could it be icon, something like that, right? Yeah. So now the more important question, what does it depend on? He said it without saying words, but he mouthed it. Anybody else? Context. Okay. Context. Context matters. This is one of the most critical parts of getting architecture right, by the way, is having a healthy and well understood problem statement. I don't know how many people I see diving into solutioning when they don't have a full concept that is developed around the context of the problem itself. It's critical, super critical, right? And the other part is abstractions are hard because we can slice and dice abstractions in many, many ways. And what matters is what context are we solving? What does the user think? What's the business need? Things of that nature, right? I may not be in a position to know. I'm the one that asks the questions, right? I am the asker of questions. All right, let's dive into principles, the core of what we are here for. Scale. Oh, the other thing is, as I organize this, I've been beaten up. I've been beaten up on some of my architecture talks, saving the best to last and running out of time. I put the best up front. So we're not going to lose out. You could leave after pizza and we're good. We're going to talk scale for a second. Talking scale. So what is scalability? Defined up here. What I like, or what I want to call out, you can see it slightly emboldened here, is that response time is linear. Interesting. Now, we do like that, right? And it is called out in the definition. I don't know where I pulled it from. I should probably put a reference up there. The reality is, I've never seen a system that is linear. Now, that really throws people for a loop sometimes, I suppose. Let's talk about it. Well, for step 1, when we talk scale, we could talk 2 different options here in the software world: vertical scale and horizontal scale. Step 1 is understanding and knowing your vertical scale. What is that? Well, how many cores can you put on? How many cores does it need? How much memory does it need? That's the vertical scale element. In the virtual world, cloud world, it could be virtual, right? So now, most of the time in the olden days, this was like a physical thing. Now it's somewhat of a gray area where it's a virtual thing. Now here's what I'm going to call out. I'm going to pause for a second. The thing I love about our industry, and I mean it, like I absolutely love it. It's this beautiful combination of art and science. So you have to be a little bit creative. You got to be artsy. You got to have science. Problem is, many organizations I consult with or I'm in, I've been in hundreds of them, if not thousands of them, they forget the science. Hey, we need more Java memory. Boop, MX plus whatever. What are you talking about? You have to profile it. You have to measure it. You have to understand it. You have to stress it. You have to know data. Then you can get artsy. We can't do one without the other. It's a yin yang situation here, right? I got to have the yin and the yang. Can't go with one thing. So there's no like guessing. I need one core. No, you have no clue. Now, there could be, with reasonable experience, something similar that you have that you've used that might be a good starting point for you. Awesome. That is great. But we have to actually measure. So we measure out the vertical. Then we can go at horizontal. What do we mean by horizontal scale? It means I create multiple instances of that thing, likely at the same vertical scale because it's easier to manage that way. We got this thing in the Kubernetes world where you have a vertical scale agent that essentially will change the vertical. I don't know if I like it. I think it's a terrible idea, actually. Know your vertical scale and then use the horizontal pod. Losing the track of the name, but HPA. So horizontal scale, we're going to talk a little bit about it. When we get into scaling and scalability, well, we're kind of stuck talking about nines. We got to get into a lot of concepts. So I don't know the order of slides that make the most sense. But when we get into measurements, we're getting in the response times and throughput. And then we see what looks like a curve. You're like, oh, the curves are bad. You had a slide that said that, Ken. We want to be linear. All right, I hear you. So I'm reusing the slide because I think or image, because I think I would have called this not users, but requests. Forgive the slide quote down there. Maybe I'll make a mod later. But this is a great slide to have a number of conversations around architecture. The first is that as you start to scale something, and we're actually, what we mean at this point is put a load on a system. And we're going to start with an instance of a thing. So we got one thing, and we're going to start loading it. And you'll start to see this curve here. Don't we want linear? Yeah. Do you see that it looks somewhat linear here, right? So all systems that I have ever experienced will hit at some point what we refer to as a buckle zone. Now, in an abstract world, I can say that it's always the same thing. When we see a curve, it's always the same thing. Something has reached its limits. What is it? Could be the number of ports. Could be the number of threads. Could be the core time. Could be the amount of memory. Could be the paging to disk. Something. Could be virtual. Number of connection pool, the connection pool limits. Could be an external dependency. I love it. There is something that is stressing the system such that it can't recover until the point that it can't respond. Then we have the amount of throughput that a thing has. Well, this line. How much can it deliver? And it also reaches a point of diminishing returns. And what we can say is this dashed line here is a close representation of both those lines being linear. And you can see that by this line, which is the summation line, right? This is a summation of these two lines. That's the science. That's true engineering, right? This is the part that I get frustrated about because I get software engineers who came out with a CS degree. Looking at you guys. No, more of a double E guy myself, but technically I was a nuclear engineer, but that's different, right? So we got to do the science. You've got to measure the system, and then we have to define the limits. The words that I have at the end of the slide, and it's something I've been using, a phrase I've been using since the late 90s, is you have to manage the things you can't control. What can't I control? I can't control the number of requests that are coming to me in some situations, right? If I'm on the public web, I have no idea. So what can I put in place so I don't have a system that melts down? Well, I put in limits for you. Now, there's a couple ways I could do limits. One is I could just drop traffic. That may not be the right experience that I want to provide, right? I could also horizontally scale. In other words, I'm splitting things. So now, if I were to take this view here, and I added another instance of it. Let's just, for argument's sake, that from this, I'm trying to verbalize more for the online listeners. Can they see me, by the way? My hand waving and stuff? No? Okay. So this blue line here at the bottom, that is from the start to the dashed line, we can see is linear. And we might put in an HPA configuration such that when that pod sees I'm approaching this by maybe 80, 90%, or maybe right on that line, this is where the arc falls in. There's a little bit of tweaking going, this looks better and that kind of thing. So I get to this point, spin up another pod. Now all of a sudden I have two of these things. And if this were representing, let's just say 5,000 concurrent requests per second, then I've added another thing that can handle, assuming the same platforms and all kinds of other things, it could handle another 5,000 concurrent requests per second. Okay, so now we can have another interesting talk, right? And I have other slides for this, so I'm a little bit leery, but it's the best point in time to talk about it. When I do that for the first time, I technically add latency. I actually reduce performance by a tad, because now I've got this other component, load balancer, that has an algorithm. The algorithm determines the latency to a certain extent. I have another thing I'm hopping through, and it has some logic to it. Now, that means I call that friction cost, right? I had 5,000, I add another 5,000, I get the impression I can handle 10,000 now. The reality is it's probably 9,000 something, right? 9,990. I don't know, pick a number, but slightly less. But that friction cost has the same line to it, not the line of the system we just measured, but it has a similar line of its own. And what that means is at the lower orders of scale, it's almost imperceivable until you reach a point where it is perceivable, right? Now, what do? I have a pod. I put a load balancer in front of it. I'm now scaling it out. I need 15,000, I need 20,000. Now I need hundreds of thousands concurrent. And I start to reach this dashed line. Now, this graph we referenced as being the graph we measured one instance of a thing for. Now we need to measure again with all the infrastructure in place. We will now look at this new graph, which will be the system graph as opposed to the instance graph. When we look at the systems graph, I'm going to be able to discover where my new load buckle zone is for a given set of a system. So I have 10 instances, I have 100 instances, and now I can start to see where my buckle zone is on that. When I get to a place where I am approaching nonlinear characteristics, now what? What can I do as an architect? I've already load balanced it. I already horizontally scaled it, and it's not enough. What are my options? Anybody? Okay. Okay, and maybe make adjustments, and maybe you do that even in the single instance, right? I love where you're going. What I hear you saying is that I'm going to profile, and I'm going to go, oh, that buckle zone was caused by a virtual thing, and I can control it. And so maybe I make adjustments. But you will get to a point, eliminating those, where the buckle zone is because of the number of ports. And now what? What, I get a box with more port capability? I open up more somehow? At some point, you start to stress physical characteristics, right? And now, when I get there, what can I do? I want to scale higher, but now I'm kind of stuck. There's a phrase, I got a quote, it's in the slides later on. You can't see it. You just have to read my mind. Randy Shope from eBay, he's awesome. Do you ever get a chance to see him? He's amazing. But I picked it up from him years and years ago. And the quote is, if you can't split it, you can't scale it. Love it. Which is another way of saying, frankly, in systems theory, you would say the thing that is the non-splitting thing, the thing that is the most constraining is what it would say, is the bottleneck. The most constraining thing in the system defines your scale, period. Is that okay? The most constraining thing in the system defines your scale limits. That is systems theory. Good topic to dive into if you ever want to get into that. I haven't gotten an answer though. I'm on the cloud, I'm living in AWS, I've now scaled this out, I got load balancers in place. What can I do? My creative artsy friends. I have to split it. How do I split it? Here's some ideas. Have you ever gone to, now I'm going to show some history. You ever gone to Hotmail? And you're like, I log into Hotmail, and then all of a sudden I get the subdomain, right? I'm logging into one system, and then I bounce out to a subdomain of Live or Hotmail. What did it do? It redirected my traffic to a subdomain, which has a whole nother set of systems behind it. Now I've moved traffic from one set of systems to another set of systems, and I have federated the traffic. In other words, I've split the traffic. What's it? Route 65. So now you're specific on Amazon like capabilities. Yeah. So, but that is a technique that we can use, but oftentimes missed. And frankly, we often are working in systems that don't require that level of scale, right? What I want to talk through is the concept. We keep splitting. Whatever is the most constraining defines the scale, right? Whoops, that is, ooh, I got a laser. Cool. Okay, these are words I don't know if I'm gonna talk through right now, but probably the most important thing when it comes to increasing performance and which can have effect on scale and scalability is really about being as close to data as possible. So I might talk about this later. I don't know. We're gonna run out of time. I can see that already. We can't talk scale without talking CAP theorem. It is a theorem, but I've never seen it wrong. So what is it? CAP. You get two of the three: consistency, availability, partition tolerance. Now, everybody expects consistency. That's just the user experience. We tend to be, but they can't get it if they want to scale. Why? All right, so scaling leads to splitting. If we're splitting something, we are partitioning the thing. If we are partitioning and I only get one of the two, I get C or A because I've already chose P. So I get C or A. I get consistency or availability. Another way of looking at that is you can actually buy this solution, right? It's awesome. You can even download it for free. XA compliant two-phase commits. What is that? That is making sure that we have consistency across two data stores. What if I told you that at some level of scale that will absolutely fail? You know what? About 15, 20 years ago, someone laughed at me and I was like, and then it was at a conference, which was funny. And I'm like, maybe I should think about that more. Like, what do they know that I don't know? and the part that I concluded, which is awesome, their level of experience, and they could be amazing. This is not a degradation of their experience, but their experience was limited to a world for which that wasn't true. If you never have experienced something, if it's never been a part of what you've had to solve, does it exist? Well, if it exists for somebody else, then it must exist, but you don't know it to be true. But I'm telling you, XA compliant two-phase commit transactions are chatty. Are you prepared? I am prepared. What do you think of this? Okay, let's do it. With some possible rollback capabilities and things like that. That's network traffic, right? And it will absolutely fail at high orders of scale, period. Now, here's the part that's interesting. You'll fight it. You'll be like, the system fell apart. We're reaching, and then you'll profile it. And I liked where you were going with that earlier. You're going to profile it. I'm going to like, can I tweak something? Could I get some indexes in place that might help me out? You're going to fight it. Why? You're going to fight it because you can buy this, which means it's completely almost free. And it solved the problem that you had. But if you're smart, you also know that if you were to get rid of it because it doesn't work anymore, you need to scrap it and you're going to be rewriting. You're going to have to. And you're going to fight it, right? You're going to like, okay, maybe I can squeeze another 100,000 requests. Like I can do that with this. Maybe I'll switch to a tighter, a more tightly bound language. Maybe I could re-architect some things. You're going to fight it. You just will. And then you're going to reach a point. And it's a beautiful thing, right? You can't scale. You're that successful. That's awesome. So, consistency is the desired experience. you're going to fight it. The rules say, because the rules change. This is the thing about being, the hardest part about being an architect. The hardest part is being aware when the rules change. When we moved to a world where I was able to provide consistency across 2 data stores, that was one set of rules. And I could play in that world in a completely different way than a level of scale that is so high that that doesn't work and the rules are completely different. All right, I can see it soaking in. You're letting it marinate. You're like, do I challenge him on this yet? I don't know. All right, so consequences. If you move away from XA compliant, then you can't guarantee consistency, period. Which means you move into a world of eventual consistency and possibly degradation of services. Which also, by the way, almost necessarily so, requires you to work in a world that programmers are challenged by. They're not very good at it. It's not common. And that is a world that requires idempotency, to be idempotent. Got a slide on it, I think, so if that loses you. But those rules apply in that world that are not necessarily true in the world that has a consistency-oriented world. And I would say, and this is important, it is insanely cheap to be consistent. Okay? It's significantly cheaper to choose the C over the A. That only works if your level of scale is capped to a level for which it's allowed. In other words, those rules apply. If you live in a world where your scale never reaches a certain point, then you should definitely choose the cheap option. You hearing me? You could absolutely create something like eBay or like LinkedIn or like X, whatever, right? You could do it. But is that the best use of resources and money for the organization you work for? And I would say it's not. Now, that's the other problem you get into. I have a slide for that, so I'll hold it. Okay, but idempotency, eventual consistency, idempotency become your new rules. And they're hard. And humans, over and over again, fail at this, right? I could go through the list. So that requires us to focus on what is business and what is non-business related, getting to the core of what you do. What is the differentiator of your organization? Let me call out eBay as an example. What is their core business? It's auctions. Do you know that it's possible, at least it was at some point, for you to register as a new user on eBay and to have an experience where like, sorry, bad things happen, could you start over again? What? Now, they're on highly available hardware, and it's highly unlikely that experience would happen. But it was determined that that's an ancillary system that is not core to their business, and we will use stateful objects to manage that because it's easy, it's cheap, it's easy to maintain, the cost becomes low, and in general, it works. But it doesn't have the same number of nines, nor is it idempotent like their core businesses, which is auctions. They pour all of their money and discipline and architecture into their core business. This is something that is challenging to most corporate architects that I see. What they do is they're like, I want it to always work in the future. I never want to look at it again. I want it to be absolutely perfect, and I want it consistent with all systems. That's ridiculous. It's not mature, by the way, as well. And it's irresponsible, in my opinion, but that's my opinion. So, oh, he got serious. You guys got serious. I'm still a friend, right? Like, still on your side. So that gets us into the 2 phases of development. You could work for a large corporation or not. It doesn't matter to this. But I have the example of a startup. When you have a startup or you're working for a large enterprise and you have a new project, you have a theory. The business has a theory. I bet we could use X. So let's build X. When you are in that phase of development, you have one question to answer. Is that true? So it is better to have the shortest time to delivery to be able to answer the question that this is a useful and a successful thing. In that world, we do light design, and we don't worry about scale so much. What we're looking to do is have a scaling problem. At some point, you determine this sucks, we should pivot. which means you have the lowest cost invested in the pivot decision. Or two, this is really good stuff, which means what? You're going to rewrite it. Most shops, for some reason, don't understand this concept. They're all in from the go. We're going to invest all of it. We're all in. They toss in all the coins. No, that is also irresponsible from my perspective. Now, I've been with large corps. It's not my preference, by the way. And I've been with several startups. I came from 8 years working at Mesosphere, which is in San Francisco. So I've been at Apple. You could go through the list of places I've been. So I've seen high scale, I've seen medium, I've seen low. And applying the right discipline for the problem is critical. But for some reason, we get in the Midwest and you're like, I don't know. I wish I understood that better. I should probably do more interviews. But there are two phases. The first phase is does this make sense? The second phase, this was successful, awesome, I'm doubling down, which means you're going to rewrite. Probably, you may not have to. It might be that the solution you built works for the level of scale of the success. Awesome, that's great. But the question becomes, if this were to become significantly more successful, what would need to happen in this system and when, at what point? Again, awareness of the architect of when the rules change. When would the rules change for this? And then put up guardrails for those rules and awareness indicators, right? I'm measuring stuff. I gave this quote already. If you can't split it, you can't scale it. Randy, good stuff. All right, some references for you later. This one's a good one, though. Maybe I'll jump to it. I don't know if it'll show up on the right screen, though. Oh, okay. This is a great site. You can just plug in any number of 9s you want here, and it will calculate stuff for you. It's kind of cool. Just came across that. One of the other principles is flexibility. Are we supposed to pause for food or anything? Okay, I saw motion, and I just wanted to make sure I was doing the right thing. There are a ton of people writing in this chat, and I don't know if somebody is collecting those thoughts or questions, if there are questions. I can't manage that and do this. Flexible software, what are we doing here? I'm on the wrong screen. All right, let's dive into it. Yeah, old traditional 90s type diagram, 3 tiers, right? I remember when they were like, hey, they didn't call it multi-tier. We started out with client server, and I remember looking at another guy. It was like, 3-tier? Are we doing that? Yeah, we're doing that. Okay. It's just a new name they came out with, right? It's like well, you guys will relate with this comment. Are you guys cloud native? What do you mean? Yeah, we're running in the cloud. But are you cloud native? Like, well, I wasn't born here, but here now. So words are hard. Marketing hijacks our terminology and it makes it something laughable. All right, so you're building a system and you're like, hey, I need to build a bridge between that silo and that silo. You know, we got a silo in this department, a silo in this department. We're going to integrate. We're doing some integration work. So, but as you look across the bridge, this is what you see, and you're imagining in a successful world, I need to manage this entropy. There's like way too many things, and you know you're going to grow. And because you know you're going to grow, there's going to be a lot of scale needs. And you think of growth in this way, and you do grow, but it kind of comes out differently, right? And the part that's interesting about this is we see lots of lines going across, and you've got a n+1 problem, or p+1, whatever you want to call it. And you're like, hey, I want to make that simple. And so then you see diagrams in the 2000s, the aughts that look like this. What was that called? The Enterprise Service Bus, the ESB. Here's the thing that's worth noting as an architect. The complexity that existed here is codified in this thing. It makes it nice to look at a diagram and point to a thing that simplifies it like it's a bus that everything just connects into. But the reality is all the routing, all the connectivity, all the things are codified here. And it's important to note that there's still complexities just baked in a different place, right? Super critical for awareness. So loose and flexible comes at a cost. I think we talked about this already. The biggest cost is this level of idempotency. What the heck is that? I said I'd mention it before. So and the part is that makes me laugh is we should already know. And I realize that not everybody is concretely knowing, and that's fine because that's my experience. Most people are not there. But I am pretty sure that the REST definition, RESTful services, requires idempotency, which means we should all be doing it. And yet what we have is what I like to refer to as HTTP RPC, right? Which is not exactly REST, right? So that's the world we live in. But when we get into highly scaled and loosely coupled systems, it requires an increase in like this. The idempotency cost is super expensive because I can't buy it for one, and I have to have deep learning experience, and I have to be able to test for it. And it's a different level of testing than functional testing. And it has similar cost characteristics as scaling to the number of nines. And what we can say, if I've been too brief there, is it's cheaper to do 2 nines than it is to do 3. And when you get to 5 nines, that's freaking crazy expensive. So I would say from a cost perspective, my experience is it's more of an exponential curve on cost. So you're going high on the more number of 9. Each 9 is not a linear cost additive. It's more on the lines of exponential. And that would be true for idempotency as well, largely because it's too, here's what that experience, I'm going to use this gentleman since he's pulling out databases and indexes. If you've ever went to a database and you're like, delete this row with this value, and it's like, sure. And you're like, did I delete that row? Delete this row with this value. That doesn't exist. Those are 2 different experiences. That's not an idempotent system. An idempotent system specifically states that if I give it the same input, I get the same exact output, period, right? Which means I have no side effects, which means that if I'm an eBay auction type organization, that if I read a record in, if I've had a system failure and I'm like, I don't know if in the queue I process that message, I could reset the pointer to an arbitrary point in time and just start rereading again. And I wouldn't get duplicate records within the system because I reread the same record. I already have acknowledgement that I have that record. I have the same exact results in my system that I would have otherwise had, which makes disaster recovery and resiliency insanely easy at the cost of development of those systems, which most engineers are not equipped for. We don't train it enough. We don't educate it enough. It's not you. It's just that we don't tend to focus on that enough. And you may not have a system that requires it. I would not go that way because of its high cost. I wouldn't be building all my systems with 5 nines. So I could also say I wouldn't be building all my systems without idempotency because it costs too much. It costs a lot for maintenance. It costs a lot for the upfront, lots of reasons, right? So, and you can't buy it. It doesn't come, you have to build it. There's just no shortcutting it. So you guys should grab some pizza. I will talk around you, but I know you guys have to be hungry. Save me a piece, preferably with meat. I'm a carnivore, but well, technically I'm an omnivore, but when do you want loose? We already talked through these questions a little bit. And then the more important question is, when do you not want loose? Let's talk performance. I think I only have a brief slide on this one, actually. We start to get to diminishing returns. Performance versus scale. We can say that it has an impact, right? It's important to have good performance. We can potentially, here's the funny part. Remember Twitter? I don't know what it's called now, but I love it that today, whenever they mention X, I don't know if I've ever seen a time they've mentioned X where they didn't say formerly known as Twitter. And I'm like, all right, whatever. So Twitter, in the good old days, back when I started using Twitter, we used to get the fail whale every once in a while, which was a whale, an image, a website with an image of a whale being carried by Tweety birds, right, across a ribbon. Why? Because their scale broke. They re-engineered stuff. They had a system which we jokingly refer to as the monorail, which was Ruby on Rails and a monolithic architecture, right? So the claim was they went to component-based or microservices, we call them now. They went to something that looks like Kubernetes today. Back then it was just Mesos, Apache Mesos, similar technology. It's how I started in the distributed compute world. No, not distributed, well, orchestration world, let's call it. And third, they switched languages from Ruby to Java and claim that the dynamic characteristics of Ruby doesn't scale. It's a nice soundbite. Can you make a good system with Ruby scale? Yeah, I think we've got some decent examples. I don't know if that's a fair assessment of theirs. But there is some value in increasing performance of your system to help ensure that you aren't the weakest link, right? In the equation for scale. I don't know if I had more on that. Why is my clicker not working? Any thoughts or questions? What should I add for performance versus scale? I think the one thing I wanted to call out is, remember when I added a load balancer in place, I actually elongated the latency, like the overall latency. It was fractional, so small. But there are times when we actually reduce performance for the betterment of the system, right? And I know that's an awkward thing to think about, but sometimes being decoupled from something is the better thing to do. Now, we could get into the opposite problem, though. And the opposite problem looks like this. We're going to do everything asynchronous, everything, because we're going to be that scalable. Like, what's the fastest way to build what's the most highly scalable website you could create? It's one that, if it receives messages, just dumps it to dev null. That's as fast as they get. We want something more than that. So you can put it in a queue, but then you're left with the problem of, well, what if the human, the user experience, the one we care about, maybe they want a response right away. Maybe that's the experience they're looking for. So if you have a system that can tolerate, thanks for submitting this, we'll get back to you. Here's a token, here's a receipt for what you just submitted. You'll get an email or come back and visit us with this receipt. Awesome, you should do it. You can't build higher scale for the most part. But if you have a system that requires a synchronous response, then you get into, oftentimes in systems I see, occasionally I should say, a synchronous asynchronous mismatch. Where you're doing funky things to try to provide a synchronous response through asynchronous systems. And that's hell. That's like putting a join or an await on everything you're doing, right? And you're like, well, I'm going to wait till I get a response. It's like, well, okay, but that may not be the best mechanism, right? So, yeah. Okay, so that's also hard to repeat all of that, but you're trying to break apart business concerns versus technical concerns. And if help me understand you correctly though, are you saying that the business concern is that I want a synchronous response, that's the requirement? But then I have a bunch of developers who built a bunch of asynchronous solutions that now I need to tie into, and so that's where we're at, right? Yeah. Yeah. Love it. Love it. Yeah. Yeah. On top of that, well, in the same vein, it's not the same exact idea. How many systems have we seen where you get into a business, pick any of them. You got MasterCard, you got Express Scripts, you got a bunch of them around here. I've been at most of them. And you have within a given system 5 different applications that require notification of a create account. And so the way they do it is looking at a record in the database, and they're like, oh, now that's me too, right? And they put a little check mark or whatever they do, timestamp, whatever. Probably a better option would be an event-driven system where I have one system that's responsible for account creation, and then everything that needs to know about it is registering for that event, with also the concept of idempotency. I didn't get the event, systems failed. I could repoint to my point in Kafka and reread and magic, right? So it's a lot of thinking. Most of the implementations of Kafka I see, at least in the Midwest, or point-to-point solutions, and you could use any queue. It's weird to me a little bit, but I mean, there's no judgment on using it. If it works, awesome. There's none. But it's a whole different commitment to get to a level of enterprise event-driven solutions. And I'm not sure what's holding this back. But to be fair to the organizations I'm referring to, a lot of times they will budget for a point solution, for a project. And when we talk enterprise, now we're talking about, I need a shared service, a shared event system that we all agree to, which has its own set of problems, monetarily and as well as organizationally. And then you get into Conway's law and all that, right? Yep. Yeah, I can't agree more. It is, yep. You know what? Takes me back. Let's talk through it just a bit, because hopefully this is useful. You guys are going to give me feedback, right? Right. I helped to rescue a project at Missouri State. I went to Jeff City for a while. Worked for Doler, the Department of Revenue. We were building a tax-based system, and for business owners. So if you're a business owner, what you know is that you pay your taxes quarterly. So you make quarterly estimates, and then everything gets worked out at the end of the year, blah, blah, blah. So the requirement that Cindy, my director in Doler, said was, we want a web page that, no, I want a web page. Now, these are organizations coming to the site to do estimates for all their employees. I'm going to file all of my employees' state taxes, right? So you can imagine that they're going to have each employee, their name, maybe their social security, maybe what they paid last quarter, an entry for the estimate for this quarter, a variety of things that help identify a human or an employee, that kind of thing. And the requirement was, we want them all on one page. It's like, you don't want to paginate? No, we want them all on one page. I'm like, well, help me again. Now, this is the consultant side of me, right? It's like, help me understand why. You have to keep asking why. What is it you're trying to, and then they wanted to eyeball it, right? It's like, well, this is a computer and it's faster than your eyeball. but I didn't win that argument. Truthfully, I did not win that argument. But now I want you to think, you have someone who's really insistent. They know what they want. They're used to getting what they want. They run the department and they're saying, just build me this damn thing. This is what I want, right? Now, how many consultants or people, engineers, would just go build it? Because when it fails, they're like, well, I did exactly what you told me to do, right? And I have no responsibility here. I did exactly what you told me to do. But I knew this was a mistake. Question for you. 2003, I think. 2003, how many people in the state of Missouri work for Walmart? Any guesses? It was just north of 43,000, okay? So what I did after having a brutal meeting is I went home and I wrote a script that generated what I expected to be an example of Walmart. And I created an HTML page, and the next day handed it to Cindy. Hey, can I have a meeting with you? I want you to open this page, i.e. version whatever, I don't even know. And it took minutes to render, minutes. Probably in the order of like 5 minutes, to be fair, but it was minutes. And I was like, Cindy, no network, no background processing, no querying the database. That's the experience. Is that what you want? Because I'll build it. But I don't think that's what you want. This is the difference, in my opinion, of one, being responsible and being a good architect and having the seasoning to know when you are approaching something where your scale limits are likely to be. Now, that limit was quite different. I'm not like worried about networking and the consistency and all this other stuff. The need to know was, what's the user experience going to be? And I just knew, right? Like, I don't know how else to say it. I was like, it's obvious that will fail. So now you start getting into questions we talked about before. At what point is it a reasonable experience and when is it not? And then when we have that cutoff, we redesigned the system, by the way, so we didn't have to go through this. But if you were to go that route, I could have one page, but the limit would be, I don't know, 100, 1,000, whatever it is. It's some number. Anything that was over that had to go through a different process. What is it you want to do? And then you have a more mature conversation. But guess what? Her answer in finally going the right way changes how I architect the whole system. Is that fair? Is everybody cool? Right? That whole conversation was because I needed to know the rules for how I proceed, and I knew what she was asking for would fail. That's it. So even if I'm an employee, I think of myself. The other thing I would say is this: I don't say no. I am a consultant, regardless of whether I am an employee or not. I am the technical consultant, and I will advise you, but I will definitely tell you why you should not. I had another project. It's a local one, so I'm not going to identify the employer, but the experience was priceless. Right? It's a joke in there somewhere. They wanted to know if you wanted to put this system. I had a new project. They want to know if we could put it on Pega systems. Now, here's what I knew. They had just bought, I don't know, it was like $3 million for Pega. And some big VP signed off on it and blah, 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 right? Now, I'm a software engineer just like you guys. You tell me, can I do something? I can do anything. Right? I can do anything. You want on Pega? Put on Pega. But I also knew that's really silly. And I also knew it was a political question. Is that weird? This is where the soft skills of architecture comes in. It was a political question. What was happening? I had a VP who has his name on a big expenditure of $3 million for that organization. It was a lot of money for that kind of system. If you could get more systems on it, it would justify itself. He was looking to put another feather in his cap and point at, see, this is adding more value to the organization than we initially thought. And look at this. What do? Again, one, I'm ethical. I'm not lying. I'm also not going to say no. What do? Simple. I come out with 2 bids. I can do that, but this is what the system would look like, and this is what it would cost. But this is what we thought the system should look like, and its cost. You might notice there is a 5x difference in the cost. Your choice. You get to choose. Right? I won't, in this case, I seriously won't advertise who, but a good friend of mine worked for an org, a consultancy org, and they're very good, very, very good. You probably have heard of them. And they always had what they call the IBM tax. If they ever have to integrate with IBM, they always charged a surplus on all bills that had IBM in there. I just thought it was funny. It's hilarious. I would now call it the Oracle tax, but whatever. Anyway, all right. Have I gone off the rails? I probably have. All right, maintainability. There's lots of ways to take that concept from an architectural principle for maintainability. Obviously, you want a system that's easily maintainable. A lot of times people think application and, not making it overly complex. I want to think about it more from an overall ops perspective. These are the 3 pillars that are absolutely essential that have to have any system that's critical has to have these. The 3 pillars: logging, and it's not just logging to disk, right? Logging would be like the Splunk or the Elk Stack or pick something, but you've got a way of getting to logs. You have, at which most people have a decent job at that I've seen, usually. Metrics. A lot of people think they can buy this. So they buy Dynatrace and they're like, hey, we've got it. Here's the problem with metrics is that most orgs are not good at it and they think they can buy it. Most of the time you want business specific metrics in addition to the technical metrics. And most of the time, the metrics that you get for free is noise. And so you have to reduce noise and increase signal. Is everybody following me? Because I'm using some abstract terms. Did you know at Netflix, they boiled down their metrics to, this is not entirely true, but for the most part, they boil down the metrics to 1 metric. It's fascinating. There's 1 metric that matters the most to them. Now, this is information from probably 8 years ago, so I don't know if things have changed. What was it? It was click to play, because here's what would happen. They have heuristics, or they've got history of information, right? They know what peak seasons are and peak times are. They know what their traffic looks like, and the metrics match to that traffic. When they see a drop in that, they may have availability issues and they need to get on it. When they see an increase in clicks, they have things that are spooling and people are stopping and replaying, trying to get the spool to catch up, and they know they might have a problem. That one metric is definitively something that is like most critical to their business. You get Dynatrace, you get a bunch of GC metrics. How many of looking at the minor and major GCs across your old space and new space, and how much does it matter to you? Right? Now, it might matter that, again, this you have to go further with the metrics. The fact that I did a GC, not interesting. The fact that I did a GC that took 2 seconds, that might be interesting. The fact that my GC went from sub-second to 2 seconds and has stayed there and is growing, very significant, right? There are things that matter, but I now have to correlate things. This is the part where we often fail, but I need to be working on metrics as part of what is a productionized system to me. The thing that is lacking in most systems that I've seen, not in the big ones, you get to LinkedIn, any of the big ones that you are very familiar, high-tech spaces you know of, they all have this. But this is the place that's missing for most of the Midwest, is tracing. And I would also advertise OTel or open telemetry, right? Everybody's moving towards OTel. It's a de facto standard. I wouldn't say it's an exact standard yet, but now it's becoming one. What is it? What is the length of time I made this call? It's essentially live runtime profiling with tracing capabilities. What is the longest pole in the tent? What took the longest? Well, and then I also have, well, this took a second, it took a second, it took sub-second, it took a second, now this took 5 seconds. Okay, I got abnormality, I can't say the word, abnormalities that caused me to be concerned, which also might be another metric, by the way. And all of these work together. I get a blip here, and I have an elongated trace here, and it goes to this log here. And I start to understand the system better. How long I'm going to stay here. Be consistent. You know what I like? This reminds me of an old joke that I used to tell people all the time. It's like somebody would show up and they just weren't consistent. And I'm like, you know what? I love that you're consistently inconsistent. You never want to stop that. The truth is, when it gets to consistency, is it can be a fool's errand. You got to be careful. When do you not want to be consistent? What you need to focus on is different levels of consistency. That may sound weird all by itself, but what you have to do is define different service levels, different service categories. Within a given service category, you want to be consistent. So I already gave examples of core business and non-core business. We talked about maybe I would use Java server faces in one, component-based front ends. And another one, I might use request-centric MVC style. For non-core business, I might use components because it's cheap, easy to reason about. It's easy, it's inexpensive, it's easily maintainable. I might be able to get cheaper labor on it, all kinds of things. In the core business, I may want a different level of consistency. But what I see is in most orgs, I want consistency across the board. I personally think that's a mistake. I think it's a huge mistake. It's not reasonable because you have to define your consistency at your highest level of concern. And now you're costing money and time and resources on things that don't require that level. Is that cool? Right? I can't be consistent all things. I can't even get the words out now. I can't make all my systems consistent with the idea of idempotency and with eventual consistency when I have a system that doesn't scale past a couple of hundred people, right? Does that make sense? Like I don't want those constraints on this system. I have to categorize things. I'll give you another example. I used to write, I don't expect anybody here has done this, but if you fly on Singapore Airlines, you might have the experience of working with GoGo, in-flight entertainment, and I wrote that system. It was the first oceanic system. What do I know about putting in a Wi-Fi entertainment system in an airplane? I have a captured scale. It can never go above 400 seats, ever. Right? Why would I design for something that's 2,000? Doesn't make sense. I also, unfortunately, had a half a gig of RAM. So I also got told I get 50K of round trip traffic per flight by satellite. And then they later came to me and said, oh, I'm sorry, that's 20K. Well, there's a huge difference. So anyway, you want to know that you're applying consistency for a category. But what does that require? It requires us to define categories and not just core business and non-core business, different levels of categories. What would that look like? Well, I might have different levels of security categories. This one's not sensitive. This is whistleblowing stuff. I have different levels of categories. Within that category, different rules. Remember, architecture is about knowing the rules and knowing when those rules change, right? Consistently, that is the message, is knowing and understanding the rules and how they change. So pro level on consistency is CAP. So high level of availability requires eventual consistency and then a graceful degradation of services. This is pro level. It's a hard thing to do. It's super expensive. What does that mean? Successful degradation of services. I'm looking at a site that has like current weather and it's mainly for commerce, and I'm selling outdoor equipment. So maybe you're correlating the weather with, the seasonal clothing, and you're doing some fancy stuff. And it might be helping your business. It might add value to the business. But when the weather service goes out, it's not the system broken. The weather system goes out, it doesn't break the entire system. It doesn't leave a box that's empty and blank on the side. It's reactive, and it just degrades and goes away. It's invisible. But that requires a lot of engineering, right? So that's what we mean. Reducing the amount of dependencies. All right, let me go quicker. Security. First of all, when we get into security, there's a great book. I have a reference in here, so don't worry. It's called Writing Secure Code by Michael Howard and David LeBlanc. But they introduced this idea that, oh, by the way, you guys remember Windows 7? Windows 7 was codenamed Longhorn. And the thing you might remember about Longhorn is it was a year and a half in the making, and they stopped. And they're like, we're going to redo things. And then it took like twice as long to get out. Now, the other thing we could say is not necessarily Windows 7, but Windows 8, the predecessor, the thing that was built on top of 7 that became 8, was pretty well known in the security world as the most secure platform that certainly Microsoft ever put out, but may have been one of the Cadillacs at the time. Why? Because Alchin, the vice president at the time, said we're going to stop all development and everybody will go through training, software training and security training before they're able to commit code, right? Now, people could say, wait a minute, you just stopped thousands of developers moving forward, but the end result is they got a product that was actually secure and actually went too far. You remember that silly experience where you're like, you need to be the number of times you need to put your password in was really high. Let's just put it that way. And then you're like, oh, and what can say, and I have a slide on this, user experience is always inverse of security. And we'll talk through that, right? But that's another one of those levers that I'm worried about as an architect. But this was introduced in their book that they were training on in that time. I always forget years, but it was Windows 7. When you create use cases, what if you also added in abuse cases? The abuse cases is how would this use case potentially be used in a harmful way? So you're going to do threat modeling, you're going to do a variety of things, but abuse cases, the other thing that it forces you to do, you're looking at security upfront, immediately. I have a use case and I have an abuse case that might tag along with it, right? Then you get into risk models and blah, 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 penetration testing at the end and a variety of things. It's good stuff. I mentioned this, usability and security always inverse each other. What would you claim is the most secure system on the planet? It's a laptop that's turned off and buried, right? You can't touch it. Not very usable. but it's secure. As soon as I put a human on it, I'm open to vulnerabilities, period, right? As soon as I put it on the network, I've added additional. By the way, I used to teach some hacking techniques. I'm thinking about diving into that again, but I used to teach how to jump on Wi-Fi's for free and all kinds of stuff, or reconfigure it. Actually, you ever get into a conference and like you can't get on the Wi-Fi because it's swarmed, it's got way too many? I'd have a cute little Wi-Fi device that would go into, it's called promiscuous mode, which is a funny name, but it's essentially invisible. But there's just a certain ping you would do that would force everything to reconnect. You just got to be the first one in or the first set, right? It's easy. So just great things you can do, but Wi-Fi, you're pretty much at risk if you're in a Wi-Fi world. There are ways, the military will have it where you have basically a cert that is required, and so you've got guaranteed security across the connection, but I don't know of any consumer models that are like that. So there's a book. It's old, it's older. I just think it's at the time probably one of the best books on the market for truly understanding security. I also think it's worthwhile. Complexity. Well, there's accidental complexity. That's a real place, by the way. Does it matter where you put the next wire? Not sure it does. I don't know if you know, but I am a private pilot. The plane, I just sold it last year, but it was 3724 Tango was my tail. That's essentially the cockpit. And what most people would say, man, that's complex. And I would say, no, it's not. And what we could say is that some things can appear to be complex. And what I would say instead is you lack familiarity. Once you're familiar, you're like, everything in here is essential. And there's a huge difference between accidental complexity and essential complexity. Is everybody okay with that? Also, there's a difference between something that's hard, not familiar, and complex. Just because you're not familiar, remember the business, I think I mentioned earlier, I have people who don't want to write and mark down on GitHub. What's their issue? They're not familiar. It's a new tool. They don't know. They've got fear. It's a human experience, right? It's real. But that's wholly different than something that's truly complex. So I bring this up. You know what? If somebody's interested in flying sometime, we should grab a flight. I've been looking for an excuse to do it. Complexity. Simplicity reduces complexity, making the system easier to, we go through the list here, understand, maintain, and troubleshoot. So we are trying to drive for simplicity within the level of constraints. So why do we not make things idempotent? Why do we not make everything asynchronous? Because those are more complex. They're more costly. They're harder to troubleshoot. Lots of reasons. If your business can stand to be synchronous and to be consistent, it's a better way. It's a much better way. But again, remember the scales. We're balancing thing here, right? I'm not trying to speak out of both sides of my mouth and send a mixed message. It truly, truly depends. And you have to look at the whole picture. Okay, so we could go through some choices, some consequences. I want to add to security. What do I know? Well, if I add to security, I'm going to have increased costs and I'm going to have increased complexity, right? So those numbers might be reversed. Here's the thing. I stole this from an earlier slide. I was going to build a whole talk at one point years ago on how architecture and architecture decisions are like playing D&D. And I was told nobody would understand what I would lose half the audience is what I was told. And I'm like, and as I brought it up and started talking about it, everybody knows what the hell I'm talking about. It's like you grab a sword and it's got a +2 against, dark, and then but it has consequences, right? It also lowers your hit points by 3 or 4, right? That is what architecture's like. When I grab the sword, it's useful. And it might be positive against one thing, but gives me a bunch of negatives, and that's what I've grabbed. As soon as I say I want to increase security, I definitely reduce the user experience. And here's the counterpoints, right? Users are just sick and tired of typing in their passwords. Why can't you just give me SSO? Okay, I could do that. And so you got to hear what they're not telling you as an architect. What they're saying is, I want more user experience. And when I hear they want more user experience, what they're saying is, I want less security. I need you to trust me. You hear it now? Like that is what they're asking for. And now you have to have a conversation. Well, does this system allow for that? Would this make sense in this environment? You have to reveal it to them because they don't know. That's why you're the technical consultant, right? You're the one that knows. Yep. Yep. I love it. Yeah, just repeating for online, but tug of war, and you don't know where it's going to end, and you're getting back and forth. I love the analogy. It's a really good one. What I would say is oftentimes some engineers or architects say it depends. And I mean, here it's fine, right? We're in a circle of friends, but when you're talking to the business, they don't quite understand. What they need is more analysis. They need us to do due diligence. They need what does it depend on. So they need a guide. They need a Sherpa, right? So you have to be the Sherpa of here are the consequences of that choice. Are these tolerable? You know, I'm going to need a variance for this standard we have in order to achieve that. Do we want to apply for this variance? That means also, because of that variance, we're going to revisit it every, whatever the cadence is, we're going to have to revisit, and you're going to put your name as you accept this risk. Great. We're all on board. Right. Yeah, we're attorneys. Yes. I want single sign-ons. I want distributed version services. This is like the most complex thing that you can do that I've been experienced with. So we have these architectural concerns. I'm kind of getting to a close here. Different types of traits, if you will. We have coupling that can be, and it's not exact, right? You're not exactly tight. You're not exactly loose. You're picking choices along the way. You have accidental and essential. You know what? On this complexity thing, the number of times I've looked at what we're doing, and I asked the question, and it's like, did we design this level of complexity? And the number of times people can't answer that is pretty high. And that's sad. I would also say that one of the things that we've done within my team that I think has been very, very helpful is we create ADRs, which are architecture decision records. So when we make a decision, we have it well documented. Here were our options. Here's what we chose and why. And in some level, to the degree that we can, we'll put in the context. So like in the future, when you look back, it's like, why did they do this? Why did they go to this? It'll actually have some level of context so you can go, but have the rules changed? If the rules have changed, this decision may have changed, and so it's suspect, right? The problem that I have now is thinking through time, and it sounds weird, but people write as if the reader is in the present day. And the reality is, for those kinds of things, same thing with pull requests. Pull requests are written to help guide, if they put any notes at all, it's to kind of guide a human through the current experience. And what we need, especially on titles, what we need is people to be as explicit as possible, such that when I need to do some archaeology in the future, I can go, oh, it can't be this because that was just a doc update, right? And they put in words that are insanely useless. Every pull request is an update, every one of them. The word update means nothing because a pull request is an update by definition. So you can avoid that word. In some cases, it makes it easier to read. I get it. So, but for the most part, if you can choose something else, you should, right? An update is completely different than create, added, removed. Update is a terrible word when it comes to any definition on a pull request. So what we need is, what information would I need to see 2 years from now to make sense of this document? That would be an ADR or a pull request. Yes. I would prefer to be as accurate as possible and specific to the business or the feature that I'm dealing with. I would also say that I don't care at all about a JIRA ticket or whatever your tracking mechanisms are as a title, because it makes sense now. It does not make sense 2 years from now. But I do need a JIRA link in the pull request description. So I want to be able to navigate decisions and understand context. But the nomenclature that we tend to see a lot of in the corporate world is ridiculous. All you have to do, in my opinion, is look at a healthy open source world, and you would see how things should be done. And so I don't know. Here's the thing: being an open source person, and I'm Apache committer, and I'm also a CNCF committer. I could show you my scars. I've been beat up and beat up and beat up just to get one pull request in. But you learn, it is the most grueling but most beneficial experience of my career. So I just advertise that. I don't even know why I advertise that. I think it's worth it. I would also submit that a good friend of mine, Craig Walls, who's pretty well known in the Spring space, he went through the same experience. He joined Spring, and Keith used to beat him up all the time on pull requests. But now he's amazing. You could trust him with anything for code. Right? For other things too. I'm just saying I don't know the rest of his life. You guys. I told you I'm explicit, but yeah, I think the rest of these are fine. We talked through some of the concerns. Controls, I talked about this earlier. You need to manage the things you don't control. If I don't know the number of users, if it's not capped, I need to figure out a way of controlling it, either dropping traffic or finding limits. If I don't know the volume of data, I got to put in caps somewhere. I got to figure out how do I manage that. As the volume, I was on a project some years ago, and they just wanted me to parse some file. I'm like, this should be cheap and easy. A week's worth of work is all you need. We'll do it in Groovy, blah, blah, blah. I built it out, tested with all of the files they gave me, and they're like, this is awesome. And then they went off, and like 6 months later, when they finally started using it, they're like filing bugs, and they're telling me how crappy of an engineer I am. I'm like, what are you talking about? And it turns out the file, I specifically asked, what's the largest file you have? And it's something small. It was in the K, so who cares? And they were pulling in gig files, and I'm like, the rules changed. You can't read all of that into memory. Of course, of course it's going to fail. It's like, you got to give me the answers I ask. Got to answer them. Some closing thoughts. We'll end it out, grab some pizza, or close down the shop. Some things from eBay that I thought were really good. Design for failure. This is if there's a thing that I I feel pretty confident in, is my ability to look at a distributed application and or an orchestrated solution and understand a number of failure points, right? The number of organizations I've gone into using either Mesos or Kubernetes that have what I call the thundering herd problem, like a dependent component way in the microservices architecture fails, and then all of the liveliness or readiness probes fail, and then the whole damn thing is rebooting itself, and now everything's trying to come up at once and bouncing around, and it's horrible. But you know what? You're going to do it until you find that out, or you could just listen to people who have done that before, right? But it's super high. You have to design for failure and understand it, right? Which means that we start to design things like this is the way, like some things I don't even remember to put on a slide. You need to define a system that has good fault domains. First fault domain is a node. Second fault domain is a chassis or a rack. In the cloud world, that would be an AZ, right? Then the next fault domain, a region. I gotta think through all of those things, but I'm looking at fault domains, and then I'm also looking about upgrade domains. And as I look through upgrade domains, they go across fault domains. So I have a matrix. I want to be able to upgrade across fault domains. By the way, this is why in the Kubernetes world, where we talk about, there's a leader election thing for who the leader is for the masters, right? Again, you can get away with 3, but we are talking about quorum. Now, this takes understanding a lot of these low-level details, right? But I need a quorum. What does a quorum mean? That means that I have consistency across, or have agreement and consistency across multiple things. Let's just call them multiple things. If I have one thing, it's always consistent with itself. It's easy. So when I'm in dev or in prod, anything but prod, usually I might just have one master. In prod, I can get away with 3. And what we're saying is I need to be able to lose something and still have some agreement. So with 3, I can lose a node and I still have 2 things that will talk to each other and one will take over. Awesome. But that's not the most number of 9s. The magic number is 5. A lot of people don't seem to understand that. Why 5? Well, in a world where I have 3, I can actually bring one down for maintenance because I need to upgrade it, have a failure, and I don't have consistency now. I don't have any ability to converse with another thing to acknowledge that I have consistency, which making 5 the magic number. But it's expensive because those aren't cheap to put up. So if you want the most number of 9s, 5. So why not 7? Because you don't need 7. It's a silly question. Don't be afraid to build solutions that meet and evolve with your needs. I love this. Start simple. Build something that you think works. Answers the question: is this a successful thing? Oh crap, it is, and it's needing scale. Okay, let's evolve it. It needs to move in a direction that that is significant towards that endeavor. You want to, again, this is eBay talking. You want to embrace inconsistency. This is really hard for humans. Even us programmers, we prefer consistency. It's hard to reason about inconsistencies. It's eventual consistency. Well, eventually, when is eventual? Right? Do I really want to show something that is not consistent or not current? Somebody just submits a trade order and they went to review the order and it's not the order they last put in, it's the one they did before. You want to have that experience? Okay, well, that's an area where you need to hone in on, right? Like you have to find it, but there is value in embracing inconsistency. And as you embrace it, you'll move towards idempotency and the ability to scale out. Now, that is if your application needs are at that level. Dependencies matter. I don't know if we're going to go into detail on that, but some great lessons on scale from eBay. It's a mistake to worry too much about scalability from the start. It's also a mistake not to worry about scalability at all. So, mixed messages, right? We're saying there should be some thought, and your level of experience will enable you to start at a better spot. But there should be some thought, but it shouldn't be the hyper focus on something that's new. It should evolve, though, and you should also make choices that are aligned with your expectations. And that can be challenging, I get that. What I can tell you is that, as an architect, I categorize all the time. It's almost automatic. But I see 2 things, and I'm like, Java server faces, component-based, great. Spring MVC, request-centric, great. They both have their characteristics. So when a new tool comes in, and all you have to do is say, this is component-based. Okay, I know what category it fits in. I know all the characteristics of that category. Huge assumptions, right? Huge, but likely true. And then all of a sudden I can know characteristics. I happen to know with high certainty that request-centric architectures seem to be better, but they're not as cheap. And so now I'm balancing a number of factors, right? Cheap, maintainability, long-term cost of ownership. This is the spot. But over here, long-term, higher scale, better in a number of categories. All right. Thank you and good luck. I do want feedback. All you. Would you leave me? Oh, jalapenos.
Microphone here, and I'll switch this thing.
I am local, so no, I'm good. Thank you. When I say local, I don't mean crazy.
Okay, well, thank you everyone for coming, and thank you very much, Ken, for giving us a great talk. Yeah, okay, so I think we can stop the recording now.